So, okay, but the function, but name of function does not allow returns not an optional. Did you mean to use stats? Okay, now we're changing this. Okay, so welcome. So I'm starting with this update error message for rethrow 2278 by Foxkiano. So, but okay, so but I have to get the context function. It should be a function. Okay, I have some. Let me just close the doors. Yeah, 1 second. A few interruptions less. Okay, so maybe his expression is throwing. Is doing a rethrow, doing a rethrow. But returns void, which isn't an optional type. Okay, so we have the context. I would think we should have the function, this calling thing here somewhere. original module, it should have the function because that is used elsewhere. So okay, the call environment. Call environment current function name. Okay, and then the returns. What does it return? It returns type quoted array string. So okay, quoted array string is something I use a lot. Okay, anyway, maybe I'll okay, I'll just look at how this feels like. So good evening, hi everyone. Okay, you remember the word? Okay, nice. So yeah, let's see. This error, this expression is doing a rethrow, but main returns int, which is in an optional type. Did you intend to use yeah, something like this, right? Good enough. So release notes. Let's see here. We are in oh, this looks a bit buggy, to be honest. So this one. What happens if I just do like, okay, there we go, normal. Okay, so improve error message when doing a rethrow in a function that doesn't return an optional. Then we have to check the maybe there's already an error for this, but I'm just going to say set this one. So optional something, optional contracts, optional something. So a new file, turn rethrow optional in non-opt C3, and then we do that, and we expect an error here, and then we'll run these tests. There we are. So okay, that was maybe I should try to get that view there so you can kind of see what I'm doing. So let's see here. So let's see, I'm just going to do this in another. So there we go. Let's use Firefox for this. Oh, I went to vendor for some reason. Okay. Right. Okay. So here we go. I'm just gonna switch here. Hang on. So media source, scene capture, screen capture, right? Okay, and then we're gonna grab what? A window. Firefox, where are you? There we go. Okay, a bit too large. Can you see it? Okay, mic level is at max. It's because I don't have any microphone, special microphone, so I can try to increase the sensitivity again. So but it's good that you tell me. So let's see if I can, I'm just going to raise that sensitivity even further. So now if I talk a bit louder, it's going to be, going to hear a bit more. Okay, so I think, oh, wait, I hope that was better. You probably going to hear my typing a bit. So is that dead? Right? What? You're saying, I guess he is dead. Okay, so com is working, by the way, but sorry, did I get something? So by the way, so leak.com. Anyway, that's the way YouTube.com would work. Anyway, so we have this issue here. Let me see if I can, make it a bit like that's horrible. Right, here we go. Okay, so we have which one? We have the improve the error message for rethrow. So this is the one, right? And okay, I have to switch to another browser here. I'm just gonna assign myself that one as a announcement. Feature milestone is 0.7, so like that. And let's see if we can get this working. So we are at hang on, switching again. Oh, it's a first hit. Okay, that's bad. Let me look at that while you are looking at other things then. Oh, my computer is a bit slow now. Oh yeah, it's because of running those tests, I guess. Let's see what happened to SE. It's like the problem when you have a server that's like running for a very, very long time and you don't really update it often. And then suddenly, something breaks and you need to fix it, and you don't know, like, I don't know anything about how it's set up. Okay, so let me see here. So we have that one. It's proxied. What? Okay. That's interesting. It was not set up like I expected it to. Oh, okay, maybe it is. So maybe it is. So weird. Oh. Okay, weird. I have to look at that later. Okay, so yeah, Cloud, they did complain about that. Let's see, I remember changing that for Edge dot for the other one. So let's see, it's a full strict. Hang on, if I change this like this, and so it's just a full one. Maybe it works now. Yeah, now it should work. So SE should work now. All right. So I got to mention something. Someone is selling something. Beginner help. Okay, I can. Right. We can look at that problem that Casey Winker had too. But let's wrap this up. So we have here. Oh, we have it rethrow. Okay, we have a different one. So rethrow optional and non-opt. So this is one. This is the expression doing the rethrow. Okay, this expression is doing a rethrow. That is the new error. Let me see that you are seeing my screen. Yes, you are almost, I guess. Oh yeah, you see it. Okay, so right, and then we have the ones that changed. So here's the one, and here's another one, and then let's see, that's the only things. Those are the only ones. So okay, I'm just going to change this. I actually did another change here that's not in the release notes. So we kind of have to write that down as well. So array size is now using our array index indices are now using int 64 and right, and then that changed. Okay, so let's grab those. Now I don't think you can see the pop-up here, so I'm sorry about that, but it's there. And I'm just going to commit this and push. And oh, I didn't run the unit tests, so better do that as well. And I'm going to update it to be fixed, and please try. So okay, so let's go to the other one. So that's done, and then we just let me show you again. Firefox is here, right? So if we reload this one, I guess it should have updated. Yes, we have another one, which seems like an error, right? So the compiler rejects bit shift operators when using enums declared with inline uint while accepting identical operations with const int enums, and that seems like a bug, right? You should be it should be doing things there. So I'm just going to copy this. Let's turn off the how come I was able to build C3 against LLVM20? Why it seems like Odin and Zig struggle to update LLVM versions? I am not sure, but I do always run integration with the latest LLVM, including the release versions. So that's I see those bugs early and I fix them. Okay, right. So we are going to look at this particular thing. This is our test case here then. So this is the one, right? Sorry, I have to change this. Right. So we have the const there. So it's a baz, and it tries to do this. This one works correctly. Okay, then we don't need to look at that. We need a main function though. It's just if I do the run here, it will complain otherwise, and I just want to look at this particular thing. So here, presumably, we get this, yeah. In order to track down what happens, I'm just going to create a main that doesn't need the standard library, because the standard library will do a bunch of stuff, and we just want to look at this particular this thing that we see. So if I jump now into binary, SEMA binary, it's just going to sorry, this is symbol, SEMA binary analyzes with inference and so on. So analyze sub there we go. So here we go. Inside of here. So we're just gonna if I just ran this as standard library, you're gonna have like a lot of hits. But here we're just gonna get one. And probably it's not flattening things correctly. So we have the expression, we are, it is kind of compactly stored. So that's why it's like that. And then we jump into this thing. I'm going to do with inference. It says, okay, so we're going to go for if the result is a shift, right? So it's initializer left. This is just going to be if you have initialized list. So we are skipping that, and then we go into the shift here. And what happens is we're going to do analyze both sides. Let's handle the initializer lists. Actually, that's like kind of duplicate of what's happening. But what happens is that we are resolving both, and then we should be, it's not going to do anything else. So we got a version here. So first of all, it's going to look for anything. Oh no, the left-hand side is not user defined, so it's going to be ignoring that. Okay, now we want to, cast the left-hand side, right, to something numeric. So that happens. And wait, if the flat one is int-like, okay, the flat one should be int-like, right? The flat one is not int-like of the flat right, so flat right is an enum, but it didn't flatten inline. So we are dead here already. So it's flattening the things, but like we should do if not type flat is int-like, and not is int-like. The flat right. Then we can just continue and say that flat right is type flatten inline something. Flat distinct inline. So we're going to go for this one. So basically, if we can't find that it matches something that is an integer, then we try to go into the inline until we find it. So what it does here is that it's going to, this flat distinct inline, it's like, actually I'm not happy about this. So while, so we're going to have like more like while not type assign integer and flat right is sub, so type is subtype is here. So no, that was the wrong one. Type is substruct. So it's a no, that's not what I wanted. Type is, I have to be something like inlineable. Type is inline. I wonder if I had something like this. It does seem like I should have already written this kind of code. Okay. So actually this flatten here is wrong. Because if you want to do like, 2 is greater than, some weird stuff, then that shouldn't work. So type flat right equals right type. It's a special thing with the canonical, sorry. So it's a canonical type. Just to remind myself that it is. So while flat type is what type is not? Hang on, it's like is it int-like, right? So flat is int-like. Why not type is int-like? Type is inner type. What's that? Okay, let me look at what you're saying. So, oh, okay, so it's lagging for you, all of you, or is it better now? Like it's not using much CPU, to be honest, but it could. Oh, I know, I can understand. I am sorry, but people are running, probably using the internet the same here as me. So we are might be a bit laggy. So I'm sorry about that. Are you still hearing me though? So maybe I should just drop this and do this some other time if it's laggy, you know. Like let me know if you want me to continue or not. So I'll. What does jump mean? What does that mean? Like do it another time is yes, or do it continue is yes. You know. For me, the stream is fine. Okay, let me continue then. So we have, we're gonna see like while the type is, you know, I have to have something like int like, so type is int like. I don't want the flat is int like, so I want the type is int like. So I'm gonna go for this one. But then we are going to say like, yes, this part, vector type, you know, okay, like this, type is int like, right, and then I have to put this here. I don't think this will happen too much, so I'm just going to, right, okay, so if type is int like, what happens if it's a vector? If not type is int like, okay, this is the flat right. If it's not int like, and if type is inlineable. It's there's type may inline. There's a question here, whether, you know, should can inline. Should I, you know, if you have this doing this after on a, you know, a vector, no, you know, screw you. This is going to be like super complicated if I do that. If type is a user defined, oh, this should be also be like on a canonical type. So switch type. Maybe I can make it work on all types. So let's do it like this. If you send a canonical type, so it's not going to be fast. So if a type is, you know, type is what? Okay, type no case type enum, case type const enum, case type distinct. I guess those are ones. So return type decal is substruct. Then the default is return false, but there's also this case type type def. Shouldn't it be called alias? Okay, return type can inline, and the type canonical. So okay, if it's a type, okay, I didn't forgot to make this a function here. If it's not inline, I mean, most of the cases this will be true, right? So if it's int-like, it's just going to be fine. Now the type may inline the flat right. So if so, then we can inline in it. So what? Type may inline. Type can inline, may inline. So okay, can inline. Can inline. Then we have flat right equals type inline, and the flat type. So let's see. If it's a distinct const enum, or it's like similar, okay, it doesn't handle enums. So yeah. Oh, it's a distinct like yeah. And this is just going through. It's not going through the enums correctly. So that's fine. So if we are, so then we have the different cases, right? Type, kind. We have the case, it's an enum. In that case, we have return type decal enums, type info type, probably canonical, right? And that's the same with this one. So const enum will do the same thing. And then we have case distinct, right? And then we have this part here, and we're just going to, return a canonical type here. Or not, or maybe we don't. I don't know. It's okay. So anyway, the other ones is default. It's going to be unreachable. So we're not going to support that. So we're going to get like, okay, we had typing, right? Type inline was that. Okay, time inline all, it's just that one. It's a static inline, right? So okay, it's here, right? We're gonna get that. So type inline all, and then so we get the flat right here, and now it's suddenly going to work here. This says flat is int-like, right? But then it's, we want to have types int-like. Right, because that one, we already handled that as long as we could. Or right. Okay, isn't like follow static. Where's the other one? Type isn't like. Okay, here's one. And there's the other one as well. In here. Okay, and this is different. Type is int or int vec. So type is int or int vec. And now this is work. Let's see. Oh, is it doing anything weird? Okay, this expression cannot be evaluated at compile time now. But that's wrong, right? So what happened here was probably... So we're going to get further, right? So we are getting to this point here. And then what happens? So we have a vector, right? And then we have, if it's, can we cast it? So the right type now is, it is a const, right? So it's okay, so it's true. Now the expression, the right hand expression is an enum. Because we didn't shift right hands. Okay, if it's an enum, so let's do it like this. Okay, if is const enum, you know, right, and that should be always be okay. Then exp rewrite, you can just cast this one, cast explicit context on the right hand side to a right type flat. And then we assert that this is a constant here. And that works. So okay, that was it. And okay, let's me see if I okay, for me times 5 fixing bugs more than blah blah blah. Why do you prefer CMake instead of GNU-Make? No, there is no preference. I don't prefer one over the other. It's just that with CMake, actually, CLion actually works. With Make, it doesn't work. And also, LVM plays well with CMake, not so much with Make. So it's just the pragmatic choice. Like, this makes it easy for me to get started and not to think about it too much. I do dislike a lot of things happening with CMake because sometimes it just breaks. Okay, but let's see here. We want to check that BAS is also what we expect it to be. So we have to be like A, B, C, D, F, right? A few of those, and then we can have a look. We need to enable the standard library again. So there are other ways to get, compile time constant, sure that it's a compile time constant, and that is to make it a just a variable like this. So we can have like 1u, and then we have to foo, foo abc, and var2 can be 1u foo df, and then we can print this. So now it should, like, we're expecting it to be like 2 and 4, right? So let's see if that happens. 2 and 4, that's the way, right? And maybe we should assign this to a something so that we can see it in the like this. Now we can make a test case about this and then see if it breaks something. Right. I'm a bit concerned when I look at the code because this should have worked, and now I had to kind of smash it until it worked. So I didn't like that. But okay, we are just doing this enum somewhere here. So new file enum inline shift conversion. So like this, and now we grab this into this test file. Okay, wait, I feel like I got the wrong thing. Oh, I probably got everything. I had some other stuff there. So I look at my scratch file. Okay, and then we need a, okay, we don't want to have this is enough. Maybe a module test. It's already a module test. We import std, but we don't need to do that, so it's not. And then we expect a test ll file with something like that, and now it will protest once we get to it. And in the meantime, we'll also, test all the other things. So stop and run. Okay, let's do it like this. So we're running that. Oh, meanwhile, I should probably update that issue as well. So I'm going to assign myself, set it says a bug, this one, right? And we are now doing it. You can see this because it's on the wrong screen here, I think. And I didn't open it. Even worse. CLion, I think CLion supports GNUMake was the claim. Well, it started to support a bit, but remember I started this project in 2019, right? And I'm just saying that it wasn't working well then. Oh, this is interesting. I'm gonna get a lot of info. So it's not defined on the right. Now we get something here. So I broke something, right? And that's good. That's good, or not good, but it's good that we found that. And because my uncertainty about this is also like it makes sense that it should have worked somewhere else. So let's at least fix this, and then we'll look at that particular case. So we have distinct sub, right? And look at this. So we have, okay, so now it's a distinct type and doing all this, right? And that's now not working anymore because of something I did, right? So let's bring that into the test file, right? And then we disable again. I'm going to disable the damn. Here we go. Disable stand library, and then find out where it goes wrong. Right. And so we have it's not defined, blah blah. So again, we get a lot of them. So it's not defined for the expression uint foo. And that was exactly what I did, right? I kind of broke that. I kind of deliberately broke that. Oh, now I know. Right? So the idea here is that you could actually cast both sides, right, to the same type. So let's have a look at that. Okay, so we are, in this case, we kind of see both of them as we're kind of flattening both sides and see, okay, they're matching, right? But what happens here? Let's jump into this. I think I know, but I'm not sure. So let's go in here. All right, and I think we are not running into there. So here we are fine, and then if I step one step through this and it's broken. Okay, good. So then it's immediately here after this one. So remember, I didn't want to just flatten it, right? I wanted to, this is the problem. So because I'm making different demands on each of those. That isn't like, right? Because that means that I can't do, did not, what the heck? So, like looking at this, look at this. It's doing a cost constraint, but it's what the hell did it do before? So I'm just going to shelve these changes here, and then have a look at what it did and why it worked. So let's shelve the fix on enums. So I know how to make it work, but it's also that would also be bad. What I mean is, this is very offhandedly, but oh, if you flatten both sides, then just go ahead. But that's a bit too permissive for type def, actually. It's like, let's say you have, a duration or an ID, and then suddenly that's turned into an int. I mean, it's sometimes I wanted, the distinct types to never do any implicit conversions, but yeah, you kind of have to have them. But okay, so let's run this anyway. Let's run this, and all of this needs to be uniform and stuff, but there's no spec yet, so we're there. So we kind of go here, and since it says okay, they are the same, right? And then because I'm the the flat versions here are fine, right? The U in both of them, so everything is fine. And then we go to the next step here. So can I cast this? Is it a constant side, constant on the right hand side? And it's like, and in the first case it is, right? So and it's just going to check that it's what the heck? It's like let's see here. So we're just replacing that. And what the heck is this type? So the type is like the left hand side or something. So the left hand side is a what is it? A uint, and so the expression becomes it's a uint. What? Like, let me look at these examples. Like the thing that if I'm just going to go for like test2 here, right? So it's going to grab test, which is the constant, but test the foo, right? And add 1 to it, so it's still a foo on the right hand side. And then I shift something with a foo, but it's not, I mean, foo is not even inline here. And what I expect to get back is actually a foo, because I started with a foo, on both sides, and it doesn't work. And the other one is still the same, like I do think those are, wrong, because like even if this was right, I mean, if it could, you could inline it, it's fine, but you can't. So that's not what happens, because it's a normal type def, so it's not actually. I think this is wrong. I think this code was dead wrong. So we just like probably said, okay, let's let's go with this, and it's wrong. Hell, this is wrong. Okay, so if I unshelve that, let's see if I had something else. But I think that's. I hope no one is using that. It's like it's really wrong. Right. So okay, let's again run these tests. If it's just that one, I'm just going to delete that. I mean, it's going to keep some of it. It's like this should be an error, because that's what it should be. It's doesn't make any sense. I mean, turning it into a like the left hand side is definitely an unsigned integer, and then you want to shift it, but you don't want to. I don't know. I mean, it just doesn't make sense to me. Not in. I mean, then if you want that, you can just use inline. But you couldn't do that before, though. I mean, it's a fairly recent thing to add, like a year ago or something. So having the inline in typedef, it was like a trick. I didn't think of it, and no one else has that. So it's just like, because converting things, like otherwise I would have to have the flattening rules kind of work in some way. I think that's what this old code was like. That it was like, oh, let's flatten it and see if it works, and then we're fine. But you have to have the same type. So this one should not be doing this. It should be like trying to get both of them to the same type. And if they're the same type, like once they are the same type, then you can do like the flatten and stuff like that, and everything will work. I think that's what I like. Try to make a minimal change here, but this looks wrong. So, any thoughts? But I have to think about that a little longer. So, shift. Okay, looked a bit. Okay, I didn't know. Okay. My eyes are like giving up. I've been like over using my eyes for so long now. I really need some rest. But I'm doing this instead, right? On top of my work. So yeah, we're still waiting. I like you. I hope you can see the cell still. It's kind of slow now. And I forgot I unplugged the. So now it's gonna be like happier. Oh, we get some more use now because of the it was unplugged and just goes into power savings mode, I think. So here it's wrong. This one is wrong, right? We want to change this. So and the way you do that is like you have something similar when you're going to do division and stuff like that. You have some smart things to that does like goes through a bunch of things, and you do the same. I mean, with everything, I guess. But just here you go. Bin binary analyze arithmetic sub-expression, right? So come on, this is the one you want. And for some reason, it's not doing the same thing. So, right, here we go. It's just you just need to copy this part actually. So if it's any integer or integer bool vector, so it's not, yeah. So let's just go and wait for this to complete, but just in case there's something else as well. Right, let me look at the stream and if I know when it's on the Discord. How you manage it all, doing a job and doing so much work on the C3 compiler. Actually, like it's yeah, sometimes it takes time, but most of it, I mean, I like programming. If I wasn't doing this, I would do something else as a hobby in my free time. But tricky part is like actually I used to do consultant work. I still do consultant work, but I used to do consultant work like basically half time. So I would spend some of the time on doing company stuff. But what are you? So I got getting this. So I would do stuff for Jake, and there's a game was a game slash is, but it's kind of on hold right now. But that's a lot longer story. But anyway, I had this gig consultant gig for like 10 years, and you get really like you kind of get used to it, and you know relying on it, and then eventually they kind of I guess made bad business decisions and shut down. So then I had to scramble to get a new consultant work, and with you know all my contacts dried up over those like 10 years. I didn't do anything else, so I had to just pick, like accept whatever I got. So now I'm doing like full time work instead of like half time work, and pretty much doing the getting paid the same. Yeah, it's kind of stressful, and actually now it's like running towards its end anyway. And actually, I would not have expected to say this, but I actually missed not having physical meetings sometimes with people. So now I haven't met people that I work with at all, ever. Just hired, and yeah, I should get I would like to get some work that would actually leverage my skills, but kind of hard to get contract work for compilers, or maybe I'm not looking at the right thing. So there are funny stories. I actually had some job like compiler related, but it fell through. They want something cheaper too, but actually, oh yeah. Anyway, so yeah, it would be way easier if I didn't have a job, just had this. But you know, that's it. It is the way it is. So okay, hang on. Did I just? Oh, hang on. Look, there is something else there that actually crashed. So we have the vector shift, right? So this one is like because I was fooling around with this anyway, so that's why it's broken. So we have the vector shift. Let's look at that one as well. So vector shift. Let's okay. So you know this is wrong, right? All this is we know is wrong. The shift or right hand side, that's one thing, but we shouldn't do this. We shouldn't use the conversions that happen because they're wrong. So we want to use instead. Okay, there's the opposite sign. It's just doing this as too. It's doing this shit too. What are the other ones doing? Like flat for arithmetics. You know. Then there is the shift, and then otherwise we're just doing. Okay. So we are looking at this then. Here, shift. So instead of this, we want to use the same as this bit op did. So it had an overload like this, right? So it's like this. Okay. So let's have, you know, the shift, it did have something like this, so we should have like overload like that, and overload shift right. Okay, and then we should have the overload type somewhere. Overload type. Probably gonna fix that one as well. I should do it like this. So I go in here, then do just using the refactoring tool. Overload type. Let's see, overload. Okay, so we have the overload, and now we are not doing that. We should go for the bit version. So the shift, do this and get the overload. And what? The overload. Oh. Match. Was that it? Yeah. Okay, so we are here. Bool and bitstruct is allowed. So false. What? Okay, now I'm confused. So what does it say? Analyze shift. Analyze bit. So it is the operator overload. Okay. Something, I just hit something and I think I broke things accidentally. Turn the shift here. It didn't like that. Something bad happened. Okay, so we are in here, right? So we have the overload. It gets the overload, and if it's true. And then what happens next in the bit version? So in the bit version, we do that, and then it's going to check that it's okay, and then it's folding when everything is done. Okay, so here we are done. Okay, so we have, right, like that. This is not, even, I don't need to do that. I need to do that, I need to do that. Now, we already, I think, already made sure that both sides have the same type, right? So this here. Yeah, I think this is true. So let's see. So if the type is not int-like, so we can go for, you know, take the left-hand side. Doesn't matter which one. Like so, left. Expression kind. If it's not int-like. Oh, and then we have to match them. Okay, but left type. Right. If it's not int-like, then we're not doing this. Then we're going to check the shifter. Right. Oh, there's one where you kind of create a vector. I guess that's okay. The flat left. Type flat and x left type. Type flat and right type. Okay, and now we can make sure that it is okay. So we can't like get an enum on both sides. That doesn't make sense. So this is going to be fine, right? So and then everything is fine. So let's see what happens now. Right, we have the on this test case, right? And now everything breaks. Right type. So I never answered the question what I was working on at the AGIC. So that was a company that founded by me and work, friend from my old work. So, oh, we crashed something. So okay, I forgot the main. It wants a main. And then we were supposed to do games, and it kind of, as it does, we kind of actually we find stuff with doing consultant work. So, okay, I don't have the forwarding function. And then eventually our games didn't succeed, the small games we did, and then we didn't. I started actually a big project, and actually this worked. So in the way this worked, actually, now I'm pretty sure. So we could test this though. We can do like echo echo test 8 food tests. All right, and we can do type of this thing, name of. Right. So now I should see what the type is if you get run test 7 here with test. My thinking is that it will be. Oh, it actually will work because okay, there will be foo. Oh yeah, this was a string type, right? So both of them trying to find something, and it's the foo. So that makes sense, right? And that works. So this one becomes a foo then, right? So it's a foo on one side and literal. So the literal can convert to foo. So then that just works. So let me run the tests here and see if it's fine. Oh, boom, right? What happened here? Oh, it's out of rate for uint. Oh, bloody hell. Bloody hell. You don't know what this is, but I know. Bloody hell. There is a reason why that didn't work. Okay, so we need to do something else here. So basically, actually, like, I have to add something to this. So because the common type can't be unsigned, it must be unsigned in this case. So unsigned bool, unsigned wins. And that one is it's unsigned wins. So what we're doing. So so S shift. Okay, I'll fix that. So in most cases it's not one, right? What the heck? Okay, it failed to update those cases, I guess. So if it is a shift, namely, and then we have like this arithmetic promotion, and then that one in turn needs to have is shift. Well, is shift. And then use the following as shift. Right, and then there's a numeric, promotion here. So if left hand side. Okay, so if left type kind equals type like this. If type is assigned integer signed and type is assigned. And type size left type equals, sorry, type size right is shift. If all these happen, so it's the maximum is an integer signed, the type on the left hand side is the same as the right hand side, and they are both integers once you flatten them, presumably. Which doesn't take into account vectors. So find max type, which will also need to be, you know, fucking, sorry. This is shit. This is bad. Okay. Type. First of all, we just have to have this if the type size are the same. So type size left type equals type size max. So in this particular case, right? And then if, you know, if we are seeing that if max, max canonical type kind case type shit type base, what's that? Because if it's a if it's a vector, then I have to flatten it and look at the base, you know, we have to look at the base type. Type base equals left type, so max, sorry, max. It's flat. This is bad. It's bad. It's bad. it's bad to make those rules kind of without thinking about them. So there is a special thing happening. So if it's a shift, right? We are not like, usually we would like to look at these types and see, if it's a shift. I mean, we already know that we should get a numerical type there at the end. Damn it. This was why a shift was special. This was why it wasn't using the other things. This was why. Well, folks, I want to think about those promotion rules, to be honest. I like, when things start to look like this, you kind of get the feeling that this is shit. And you shouldn't keep it. Right? Like, just the thing that I promote through the vectors is pain, and should be like, if there are a lot of code here trying to figure this out, right? What the promotion should be, then the rules are complicated. If the rules are complicated, people won't understand what it does. That's why this is bad. It's not like bad because I have to write some code. It's bad because people will have to think about this, right? Because we have like the concept of the max type, right? Which is where you kind of, if you have ints, then you kind of look at the biggest one, and then you have like an enum, and then try to find the maximum and something like that. This should go, like, if I look at this, I get a feeling that this should go away. Like the type enum here. Like, you have an int, right? And then you trying to find the max type, and it shouldn't be an enum. Right? The fact that there's an enum here is a red flag here. Right? So, of course, if you have like two interface and you see the rules here, right? So if you have, you want to go to a more generic type, right? So trying to find it. So if you have ints, right? So typically, then you're gonna go here. Let's see, it's a distinct. If it's a numeric, and then you kind of go to trying to see if you can convert it or something. And this is kind of, it's not good. It's not good. It's like, let's throw this away. I get so annoyed. Like, this work that we did, it's just throw it away, because this bug is worse. Like, the fix is worse than the solution. And I was thinking like, oh great, this, we can do it, make it even easier. But no, it's shit. It's bad. So bye. We just keep that thing, and then I just have to step back a bit and think about this, right? Because conversion rules, like, they end up complicated. It's like parsing rules, right? You want simple parsing rules because people can remember those parsing rules. But if you start, if you're starting writing a parser, there's a problem, because you can easily hack things as you go down, like recursively. like, oh, I can just look at some token here and doing this there, and then if I know something, I can do something else. That's how we ended up with the C parser, where I can look up the symbols. It's no problem, because we do it top to bottom, and you kind of get those kind of hacks. So what I don't want any hacks. I mean, the max thing here was kind of clean before we started with the hacks, and then it's like, what's this? One of the things is like, if you have a vector of something, can you then convert that vector into something else? Like what is the maximum type if you have like a, let me show you. So if I have, throw this away, like I have an int vector, right? It's a problem working with vectors. So if I have an int vector, but it's not like it's just like it's not just right now an int vector. It's just like this, and and then you want to have like, you have maybe something else which is like a pointer. So you have a pointer vector. So we start with a pointer vector p here, right? And then you want to do like p plus equals, and then infer that to the right thing and stuff like that. So in that kind of case, you want to look at what is the or no, actually even better, you have like, we have foo. So we make a type def int foo equals int, right? And then we have this array of foos, and then we want to plus something, and it's like, it's an int, but it's a constant, right? So maybe you could make this this constant convert into an array of foo. So that's what you want to do. But to do that, you kind of have to, like in this case, right? But if you have, what happens if you have like this? Maybe you have some var here, so like this. I can create this kind of situation, but basically like this. This is a constant thing, constant struct. Sorry, it's constant vector, and this is like undefined. And here you kind of want to find, you want to convert the other one, like everything to foo, basically. But if foo is inline, do you want to convert to int? It's it's a problem. Like ideally, why do you do that when you can have this, but you can have maybe things coming? I don't know. Like I would always want to do that, right? So maybe we can just, maybe we could get rid of that conversion, that distinct promotion into a vector, because things will work anyway. Let's see what happens. So what I mean is, we have like the find max type, right? And this find max type kind of goes into the vectors themselves. So let's see, we have a vector somewhere. Oh wait, there is no implicit conversion between vectors, so it's not there anyway. Ooh. Right, so in this case, like we have distinct and non-distinct, and then the distinct one can, convert into an inline version of itself. This is what happens in the max. But I wonder, I really wonder about this one. What tests break if I do this? I'm not sure any tests will break. Like, yes, of course, the first one, but not the others. And there's also like if one is a vector, then we always go for like assuming that it's gonna converge or something, right? And if it's, it's a distinct other, or if it's a num type, we can find that one. So max num type, let's see what that one does. Right, so it just goes for the unsigned signed. And then we have this, unsigned is unsigned plus unsigned returns, the big one. But unsigned plus signed is going to be like assigned. So that's the problem here. But look, it doesn't do anything. Oh wait, there is one here. Okay, that was one we are working on, right? The inline inline shift conversion. But yeah, I'll just gonna have to think about this a bit. So someone was, I think it was Windy Castle. Like you said something about like how would you have time to do this, right? But a lot of this is just has to mature in your mind. Kind of, you have to think about it, think about all the implications of whatever decision you do. Can you see that happening, and try to anticipate as many of the problems as possible. Like you can't anticipate all of them, but as many as possible. And I know, that people are really enthusiastic when they start learning language design, and they kind of, oh, I have an idea, let's implement that. Without like really thinking about what would be like, what's the consequences of this, like what are the repercussions. But yeah, I guess I'll stop here. I have this other thing that I could do though. It's another improved error message. But yeah, I'm thinking like this. I think this could be enough for now, and I want to think about this a bit. Uh, Making the rules easier, that's always a priority. So you really don't want to have complex conversion rules. But shift is really weird because shift is like you have one value in the shift, which is like the important one. The other one's just probably just going to be an int. Sorry. Between like 0 and 32 or 63 or something like that. It's not going to be bigger. But it could still be, what if it's an enum like this example? What if it is a distinct type of something? Does it promote both? If you take like one case where it wouldn't work, of course, if you like had some distinct type bar, and then you have a foo, and you wanted to take bar and shift it by foo, then of course they wouldn't match those distinct types. But there's a special case when you have a constant, right? So because then you can kind of convert that constant to whatever type you had on the right hand side. So, but you can also do like, okay, let's convert everything to the, try to implicitly convert it to what's on the left hand side. That could also be right for shift. So that's a tricky thing. Like the type of the right hand side is not important. in general. You want to keep the type on the left-hand side. But on the other hand, what do you do if the right-hand side is much bigger? So, or different type. Maybe like I don't like. There's a good argument for you just having to that you really have to have the same time. But on the other hand, like if you have something shifting and then the left hand side, like if you have this, try it again. Okay, if you have this, check this out. Like you have foo, right? And then you want to say like foo is 1 u 1 and then shift, foo x foo 0, right? Should that infer that it should be like what should happen? Like actually, if you have some constant like that, this will always work. The weird thing is like if this one is like a for u is like it's like this, right? Then things get weird because like what is the type of this one? So I don't like having to make casts, right? So but we could make it like this. Or in this case, like actually, like I think what happens here would be like this is what happens here? I think that would be an int and it would be rejected at this point. Okay, we're almost done with the test, by the way. They are stacking up. Okay, so what happens if we do like this? I think this might be an error, right? Yeah, so implicitly casting into foo is not permitted, but you may do an explicit cast by passing. Yeah. So this is, I think this is surprising. And actually this is the result of the way it works. So it will try to flatten everything. It's like, it's just bad. It's just bad and broken. But what should the rules be? What should the rules be? That's the trick part. Actually, this is also very, very broken when you have untyped values, by the way. So you really want to type that one inside. Making implicit conversions that make sense is not easy, actually. So that's it. But okay, thank you very much for listening to me, and I will end it here. But thank you, and I don't know if you have any other questions, as you are like before I quit. So do let me know. I can just patch this particular thing with the enums. Just have to make the test here. But that particular thing that that was so with the max there, that one should go in. So it was the one where I was like looking at the enum and trying to do some implicit conversion that I think there was less left over. Do not do certain implicit conversions on enums. In expression. I think like the cast rules will not permit it anyway. So So no questions, then I will end there. So thank you for watching. Have a good evening.